Um, all right, so let's get started. So this week I posted an announcement about the projects. I know some of you are interested in doing this. So you can either do that if your quiz scores are not great, so I'll just take the maximum of your project credit and quizzes. So just send me an abstract, just like one page of abstract. I mean, just like one paragraph, even one paragraph is enough. By Wednesday, this Wednesday, okay, not November. So I mean, you can have your own ideas. I encourage you to come up with something that you are more interested in. But so like two ideas that I can suggest you are, one is open source software contribution, of course in Python. So if you find some kind of library that you like to use, and then if you look at its GitHub and then look at the issues, then you can decide, oh, I want to fix this issue. Okay, for example, for some machine learning library, let's say GitHub scikit-learn. For example, this is the GitHub repository for this very popular machine learning library, scikit-learn. If you want to make a contribution to this library, you can, for example, look at the issues, okay? And then, so there are so many open issues. You can actually pick one of those and then start working on it. But make sure that it's not really, really trivial. So I want to see that you actually understood the whole library and the problem really well, so you can contribute. And if your pull request gets accepted, of course you'll get full credit. And that will look really good in your resume too. If you can say that you're an open source software developer, you know, then people will take your Python programming skills more seriously. And so it's also, you are lucky that you have been dealing with GitHub during this course. So I believe it should make your life easier in order to make contribution to open source software. So, but this is just one idea, okay? So, and this is just one library. You can pick something else, whatever you are more interested in. Or you can actually design and modularize a program. So let's say you are interested in some data science project, okay? So you can define your data science project where you have the data loader part, you have the model part, you have training part, and the results part. So put everything together in a more compact way. And I don't actually, for this project, I don't expect any kind of report or anything. I just want you to have a GitHub repository again, where you define everything, each step with the README files. For example, so again, if you look at scikit-learn, here you see, so it actually explains things, or in our assignments, for example. So for example, in our assignments, I had these README files where you can actually explain what you are doing, or not just the assignments, even for example, for the lectures. For each lecture, I have a README file where anyone who is interested in the material can easily follow. Okay, so this should be the output of your project, and so it depends on the number of people who do a project. We can actually have some kind of a presentation, maybe 10 minutes, 15 minutes, you know, for each project. It will be more like going through what you have done, and also more like a demo of your Python code. So, and the deadline for the projects is November 30th. So you have a little bit more than a month, okay? And once we decide for the projects that you are gonna work on, I'll meet you every week to track your progress. So during my office hours, you'll come every week, and we'll make sure that you are making a progress or you are not stuck. Okay, so I'll do my best to unstuck you. So that's it about the project. So any questions about this? So who wants to do a project? How many? 1, 2. Okay. Okay, maybe we'll have time for full presentation. All right, and also, so don't do it just to get a credit. You can do it more like a showcase for your resume. Okay, you can put it to your resume and say, hey, look, this is what I did. All right, so that's about it. And last week we didn't have chance to actually go through the quiz. So let's quickly go through the quiz. There's not going to be a quiz today, so you can sit back and relax. Okay. So, did you go through the quiz actually last week? We didn't, right? We did? We didn't, okay. All right, so for this one, this was easy, right? So this is a recursive function. And do you remember the answer? So this actually finds the greatest common denominator. So it is actually 6 in this case. So this one, the second question, we have a list of functions. So each item in this list is a function. So the first one takes x and then computes the square, second one takes the cube, and so on. And when the input y is 2, then, so first we call g0, which only takes the square, and then the input is y, which is 2, so the answer is 4. So this question was about generators. So basically, your function takes a string, and then, okay, so if you want to have a conversation, can you step out, please? Okay. Again, there's not going to be a quiz, and you can watch the video later. I won't get offended. Everything good? Okay? So, all right, so this function, this was about generators. So we have this function, and then, so it takes line as a string, and then we split it, and every time we yield the uppercase of this. So since this is the input, so first time when we call next, we will get xxx, and the second time when we call it, it will be yyyy, right? Is this clear to everyone? Okay. So this one was more, if you remember from last week, it was about reducing. So we use lambda to actually, okay, so G actually takes a function f and a sequence, and here our function takes the summation, and then over a sequence we compute this summation, and we return the output, which will be the summation of all these, which is 10. Okay? All right. So now let's start with the new topic. Okay, so object-oriented programming. So this is, I think this might be the most important class of this course. So please pay attention. So first, let's start with the idea of object-oriented programming. So basically, So classes are Python's main object-oriented programming tool. So the basics are, so here is a metaphor about object-oriented programming basics. So let's say we have this hypothetical pizza-making robot, and we want to implement it using classes, so we can model more of its real-world structure and relationships. So there are two aspects. Yes?
Could you share this right now? Because I cannot see what's written.
Right now. Okay, let's see. But so it's gonna, it might change, So I like to actually upload something after the class. But let's try just for now, So I'll update it. Huh?
Just post it on the canvas.
Oh, push it on the canvas? No, I think I can do it here too. Let's see. Yeah, it may not be the final version. Okay. Oh, sorry. Sorry, it didn't put it there. Yeah, I put it. Okay. All right, so it should be in the public repository. So can everybody see that now? Only if you want to, if you want to follow it from the IPython notebook that I'll be illustrating. But I might be changing it a lot, so yeah, it will not be the final version. Anyway, okay, so let's continue. We are making a pizza making robot where actually we want to use two object-oriented programming aspects. So one is inheritance. So basically pizza making robots are any kind of robot. So we can actually just inherit the properties of a general robot. So what robot needs, whatever task robot does, so it's independent of what the robot is doing, but every robot has some common properties. So we can inherit this for our pizza making robot. And then other aspect is the composition. So, pizza making robots are a collection of components that work together as a team. So for our robot to be successful, we might need arms to roll the dough or motors to maneuver to the oven and all that. So for object-oriented programming, our robot is an example of all these compositions. So it contains other objects that it activates to do its bidding. So each component, you can think each component as a class which defines its own behavior and relationship. So this is, of course, very, very hypothetical situation. So in terms of more concrete programming perspective, so classes are just Python program units, just like functions and modules. And they are just another way to package logic and data. So, but it's important that they actually define new namespaces, much like modules, but they are different than modules, which we will discuss about. Compared to the other units that we have seen, you know, lists, dictionaries, whatever, so classes have three critical distinctions that make them more useful when it comes to building new objects. So one is multiple instances. So you can think classes more like factories for generating one or more objects. So every time when we call a class, we actually generate a new object with a distinct space, a distinct namespace. And inheritance that I just mentioned, so customization via inheritance. So classes also support this object-oriented programming notion of inheritance, that we can extend a class by redefining its attributes outside of the class itself in new software components coded by subclasses. So this is that actually increases the code reuse. You know, let's say someone already wrote a robot class, and then I can easily inherit someone's code and then start writing my own pizza making robot function or class. And operator overloading. So by providing some special protocol methods that we are going to discuss, classes can define objects that corresponds to the source of operations that work on built-in types. For example, you can define your own print in a class. So you know Python, we have this print function. You can overload to Python's built-in print function by defining, by using some special protocols that we will illustrate soon. So in Python object model, classes and instances you generate from them are two distinct object types. So one is the classes that serve as instance factories. And their attributes provide behavior, data, and functions that's inherited by all the instances generated from them. So you can think it more like a blueprint. Let's say you have a blueprint of your apartment, and then I use your blueprint to make my own apartment. And then someone else can also make their own apartment using that blueprint. But we have this blueprint, which is a classes or a factory, you can think. And instances, they represent the concrete items in a program's domain. So in my example, my apartment is an instance of that blueprint, right? So their attributes record data that varies per specific object. For example, okay, so maybe here it will explain it better. So the primary difference between classes and instances is that classes are a kind of factory for generating instances. For example, one realistic application is that we might have an employee class that defines what it means to be an employee. And from that class, we can actually create employee instances for Bob, Sue, whoever, you know. Or given an employee, you can actually inherit this employee class to generate an engineer class, which is more specialized version of employee. But it will inherit all the properties of an employee. Okay, so it has been really abstract so far. So for example, in this figure, we have a class tree with two instances at the bottom here. You can think this as like one employee, let's say Bob, and the other one can be like another employee, which is Sue. And let's say they are both engineers, so they both have so they are all created by using a class, C1. Let's say it's an engineer class. And let's say that engineer class actually inherited the properties of an employee and also something, I don't know, let's say human, you know, like two different classes your C1 class inherits. So C1 inherits C2 and C3. They all have their own attributes. And by using this class C1, which in our example is an engineer, we create an instance I1, let's say an instance for Bob, and another instance for Sue. Okay, and all of these objects are namespaces. So they are actually packages of variables. They have their own namespaces. And the inheritance search is simply a search of the tree from bottom to top. So let's say I'm looking for the attributes Z for this instance I created. First, I look at here. I couldn't find Z. I go up I look at the class C1, and I can't find it. And then I go up, and now here you go. So it could be actually either this one or this one. It depends which one was inherited first, basically. Okay, so it's important that the attribute search goes from bottom to top. Okay, so now let's start more like coding. So I actually encourage you to code if you can. You can start an PyCharm or IPython notebook to actually get your hands a little bit dirty with classes. So, for example, in this case, so in this figure, I'm going to create two classes, C2 and C3. So this is how you create a class, basically. You just say class C2. In this case, it does nothing. I just say pass, basically. It's almost an empty class. And I define another class, C3. And similar to C2, it still does nothing. But I just define two empty classes that I was showing here. But I didn't add XZ or WZ yet. And then I create another class, C1, that actually inherits C2 and C3, which now are the super classes of my class. So if you look at our picture here, we have C1 that actually inherits C2 and C3. So this is how you define it. And of course, again, it does nothing. I just have pass. But here I'm showing you how to define a class from really basics. And then I create two instances, I1, using this class C1, and then I2, again, this class C1. So these are two distinct instances now that I created. And if you look at our figure here, you can see that. So I1 is one object, and I2 is another object. Okay, and for I1, if I look for some attributes, it will actually first look at the attributes from C1. If it cannot find it, it will look at C2 and then C3. All right, so this was the most basic case. So classes provide behavior for their instances with method functions. We create by coding with def statements, as in functions that we have seen. But you do it inside a class statement. So let's say now we make our class a little bit more interesting. So our C1 class, it was actually empty before, and now I define a method. So when functions are defined inside a class, they are called method. So I define a method here, which says set name, and it has this input self that we will talk about, and then it takes parameter who, and then it sets self.name to who. So basically here, probably the most interesting part for you is this self, right? Why am I inputting self to this function? What does that really mean? So this is, if you are familiar with Java, this is actually what you use as this in Java, similar. So here you can think self as more like an instance itself. But when you use it, you don't actually type it. So for example, I make these two instances by using this class C1, right? I say I1 is C1, and then I2 is C1, and then I set the name for I1 to Bob, and I set the name for I2 to Sue, but I didn't use self here. I didn't input self. So it actually automatically knows that for self, I know that this belongs to this method belongs to this instance. So you don't need to input it. So all you need to input here is actually the parameter who. And our who parameter in this case is Bob. So it defines I1.name as Bob. And for this one, it defines I2.name as Sue, basically. And then when I say print I1.name, it of course, since it set the name to Bob, it prints Bob. Okay, so this is how you define a method inside a class. And the most interesting part here is self here. And we actually define an attribute of a class, which is like self.name, to whatever you input here. And then when you call your instance with its name and also the attribute's name, we can have access to that attribute, to that variable. Is this clear so far? How you use classes and how you define a method inside a class. All right. Operator overloading. So this is actually what I mentioned at the beginning. Like you can define your own prints, or you can use some specialized functions. So if a class wants to guarantee that an attribute like name is always set in its instances, it's more typically will fill out the attribute at construction time, like this. So here, again, I have this class C1 that takes C2, C3 as superclasses. And here, so this is the method that you will see almost in every class. So this is you define it with double underscores and init. So when you start, when you initiate your instance, when you create your instance, it actually runs this automatically. So this is a special function or a constructor. Basically, in this case, I define this init, and so automatically I can start my instance with a variable name who, which I assign as Bob for I1 and Sue for I2, and then it automatically once you start it, it automatically sets self.name to this variable who. So you don't need to really run this function set name. Okay? But pay attention that, so yes, this uses double underscores, but if you remember, we also have double underscore pi functions to actually do the relative imports. This is different than that. Okay, remember we had underscore init underscore .py functions to be able to import different modules. So it's not the same thing. Okay, so if it is coded or inherited, Python automatically calls a method named init each time an instance is generated from a class, like just what we said. So the effect here is to initialize instances when they are made without requiring extra method calls. And of course, they are optional. If omitted, the operations are not supported, of course. So if no underscore init is present, then we will return an empty instance. So for example, if we didn't have this, so if we didn't have this init method, and also we didn't have this set name method, and we don't run it, then when we try to access the value of I1.name or I2.name, we'll get an error because we never ran it. Okay, so polymorphism again. So suppose you are assigned the task of implementing an employee database application. So as a Python object-oriented programming programmer, you might begin by coding general superclass that defines default behaviors common to all the kinds of employees in your organization. So basically, when you actually run a big program, when you write a big program, you need to first sit down and decide how to define these classes and what relationship you should have between these classes. Which one should inherit what? Which one should be more like a higher level or bottom in the tree, all that. So people usually spend some time before really getting, before starting writing the code. Okay, so in our case, we have this class employee that we define, and we actually introduce 4 different methods for this. Of course, now at this point, they don't do anything because I have pass function here. So I say, okay, compute salary is one method, give raise is another method, promote is another method, retire is another method. But notice that they all have self as an input, which is important, okay? And then, so this is the class for employee, and there is really nothing much special in this case. But once you have coded this general behavior, you can actually specialize it for each specific kind of employee to reflect how the various types differ from the norm. So for example, compute salary. So the salary might be different for different jobs, right? So you can take this employee class. So I create another class called engineer that actually inherits employee, and I define a new method, compute salary, which of course again takes self, although I do nothing here, but this actually overrides the compute salary you had here. Why do I need this? Why would that be useful? Why should I overwrite? Because so for different kind of jobs, you might have different salaries. So for engineer, your compute salary might be different than a manager, for example. But retire might be the same thing for everyone. So you may not need to define retire for different job categories. Or give raise might be specific to some certain type of jobs too. So basically, it is more like, okay, so take whatever I have here, and then I want to overwrite it for engineers. So when I start an instance that uses this class engineer, and when I say compute salary, it will actually compute the salary that corresponds to this class instead of the employee class. Because remember, so in our class 3, employee is in higher and engineer is in lower, and we go from bottom to top. And since in the bottom we have engineer, we actually compute the method that we defined in engineer first. Okay? All right, and now we can create instances of the kinds of employee classes that are real employees belong to get the correct behavior. So for example, we define an instance, Bob, with using employee class, and then we define an instance, Tom, using an employee class. But for Sue, let's say we use an engineer class. So for Bob and Tom, we will use the compute salary for the default behavior that we learned in this employee class. But for Sue, who is an engineer, we will actually compute the salary using the method we just defined in the new class that inherits the employee class. And so ultimately, these 3 instances objects might wind up embedded in a larger container object. So for instance, we can use a list for this. So let's say I have a company which has 3 people, Bob, Tom, and Sue, and now for each employee in my company, I can actually print the compute salary. But here, of course, it just returns none because, my function doesn't return anything. But now let's change it. So let's make it return, I don't know, let's say 100K for an engineer, and let's say return, let's say 60K for a regular employee. Okay. And now I import employee and overwrite the compute salary and define my instances again. And so make my company, which is a list of all these instances. And now when I compute salaries, it's going to compute the salary, which was 60K for Bob and Tom. But for Sue, since she's an engineer, she makes more. So it's 100K, basically. So we just overwrote the function. Is this clear so far? Any questions? Okay. Okay, so how is this related to polymorphism then? So remember, polymorphism means that the meaning of an operation depends on the object being operated on. So in this case, Bob and Tom were objects of employee class, but Sue was an object of an engineer class. So compute salary depends on what object we operated on. So that's why we got a different value for different object types. Okay? All right, so let's start doing maybe a little bit more complicated stuff. So let's say we define the first class as first class, and it has 2 different methods. So it has set data that takes itself and also the value. And once you take the value, you set the attribute of this instance, the data attribute of this instance to this value. And then when I say display, I just display self data. Okay? And again, remember, so we have self for both cases, and we have the attribute of data for this class. And we have 2 methods, set data and display. And now let's make 2 instances using this class. So one is X, one is Y. And so here, I don't need to input anything because I don't have any initialization init function with double underscores. So that's why I can just initiate them with like nothing. So here we have 2 instances, and each has different namespaces. So properly speaking, we have actually 3 objects. So 2 instances, X and Y, and a class, first class. So we have 3 linked spaces as shown here. So we have X and Y, and they both are generated using this first class, which actually has this set data and display. And they both have their own data here. So actually, most of the time when you work on a design for a program, this is how you use. So this is the way you show that, okay, I know that this class has these methods. I know that it has an attribute, data, all that. So classes and instances are linked namespace objects in a class tree that's searched by inheritance. So here the data attribute is found in instances, but set data and display are in the class above them, basically. Let's say, for example, So for the first instance, X, I can say set data that takes the value King Arthur. And for Y, set data is just a different, it's just a float. So in this case, neither X nor Y has a set data attribute of its own. So Python follows the link from instances to class. And that's all about there's to inheritance in Python. So it happens at attribute qualification time, and it just involves looking up names in linked objects. So here, by following ISA links in this figure, it finds the set data and display methods. So because classes can generate multiple instances, methods must go through the self argument to get the instance to be processed. So here, each of these self actually are required to run them in an instance. So when I say x.display, it displays the data, self data, and for x, and this is the this one displays the self data for y. So they both are different because they both have different self data for each instance. And now let's say we want to change the attribute in the class itself. So I just set the x data by running this set data for x, but I can actually change it. I can say, let's make x.data as new value instead of King Arthur. And now when I run it, of course, it's gonna now give me the new value that we just assigned. So we just changed it, and we didn't need to run the class again. So once we did this, it made self.data equal to new value, and now when we set display, we were like print new value basically. All right. Well, this is less common, but you can also generate an entirely new attribute in the instance's namespace by just assigning to its name outside of the class method functions. So you can just, for this instance x, you can just say x dot another name and spam, and then you can see if this works. So now when I look at its attributes by just running this dictionary method with double underscores, now I have both data and another name. For example, if I do that for, I mean, don't worry, we'll talk about this underscore dictionary thing, but just to illustrate that by running this, we just assigned, we just created a new attribute for this instance, but not for the other instance. So basically, the other instance, y, it only has data, but our instance has both data and another name. But this is, I mean, this is something you can do, but it's really not that common, and I don't recommend it, to be honest. You don't want to change things outside of your class that much. Okay, so now let's illustrate the inheritance. So instances inherit from classes, and classes inherit from superclasses. So to illustrate the role of an inheritance, so let's define this new class called second class. So this second class inherits the first class. What does that mean? So I have this first class here that has two methods, set data and display. And I have this second class, which actually inherits from first class, but it has its own display function. So by defining this new method, we are actually effectively overwriting of display function in the first class. And now we can create an instance, Z, that will have the data. So Z is just a second class. So when I run z.setData, it actually, so in this figure, I have this instance Z, and it looks for set data in the class that it used to create, but it doesn't have set data. If you look at second class, it doesn't have this method of set data, and then it goes one up in our tree because second class inherits first class, and then it looks at here, and then it finds display here, and now he's like, okay, now for z.setData, I know that I need to use the function here, defined in this class. So in this case, so when I run this, it actually finds the uses the function in the superclass, and then, but for z.display, so I had this instance Z, and then it looks for the display method in the class that it used to create the instance, and it finds this display in the second class. So we are like, okay, we don't need to go further up. We just found this display function in the closest class to the instance. So it uses that z.display using the second class. So what was the difference between the display in the first class and second class? So the first class had display that just prints self.data. But in our second class, we have something a little bit more complex. So we say current value is self-data. So that's why, since that's the closest to the in terms of the tree link for the classes, that's the closest to the instance. It actually runs the display method of second class that we just defined. Okay. But here, what is important is that the specialization introduced in the second class is completely external to the first class. So yes, here we have the second class that actually takes the values from the first class, but it doesn't change first class. First class stays independent. So we are just inheriting first class to second class, but not vice versa. Okay? All right. So what is the difference between classes and modules? So classes are actually attributes in modules. So let's say I define module in my PyCharm. Let's say why does it need why does it create okay. All right, let's change the name. No, it shouldn't be. This is strange. It doesn't let me create a file. Let's just rename this my classes. Okay, and let me increase the font. Okay, so let's say we have this, we define this first class that we just had here. Okay. Anyway, so the name of the module is my classes, and the name of the class is a first class. So this first class is actually an attribute in this module, my classes. So if you want to import it, you can basically just say you can say from my classes import first class. Okay, so it finds my module, my classes, and then it imports the class I want from that. And then once you have it, you can still define you can still define your class, second class, using this first class. Let's just say pass. Okay. Or you can also do import my class, my classes, and then you can define class, second class, using my classes dot. See, it actually auto completes first class, and then you can just say, you can just implement your class. So basically, this is just to show that you can either import the module and then call the class as an attribute of that module, or you can actually just import first class from this module, my classes, and then use what you just imported when you define another class, which is second class in this case. All right. So it is important that the common convention in Python is actually that class names should begin with an uppercase, and the module names start with a lowercase. So it will be really you can actually give the same name to the module and the class. Let's say I can have this first class, and I can also have this the name of the module as first class. But when you do that, it's usually you usually define your module with a first class that starts with lowercase f, and then when you define a class, you start with an uppercase. This is just the standard. It is to show that what you are importing is actually a class. That's why you start with an uppercase. Okay, so again, operator overloading. So it lets objects coded with classes intercept and respond to operations that work on built-in types like addition, slicing, printing, qualification, and so on. So here, what you should probably pay attention is that the methods names with double underscores, let's say double underscore x double underscore. So this x could be actually anything, are special hooks in Python. So such methods are automatically called when instances appear in built-in operations. For example, an instance object appears in a plus expression. You can actually overwrite it. You can overwrite what plus means for an object. And so there are no defaults for operating overloading methods. and none are required. So if there is no add with double underscore, then plus might raise an exception. So now let's define this third class that actually inherits the second class. So in this case, we had the second class, and then we have this initialization method with the double underscore in it that actually takes a value, and it assigns that value to your data. And I define an add method that actually takes self and also another value, and I again return another object, which is also third class, that actually sums the value that you had with self.data and other. And also you can also define this str with double underscore, which actually replaces your print function. And you can also define so here we actually define another method that actually takes the instance itself and then takes other, and it just multiplies in place. Okay, so basically when the init is run, when this is run, the self, so init is actually run automatically when a new instance is created. And add is run when third class instance appears in a plus expression. So this replaces the plus expression. And this is run when we actually print the object. So for example, let's see what it does. So let's say I define a class, third class, that takes a value ABC. So it automatically calls this init function with double underscore. And here the inputs are ABC. Okay, so what does it do? So ABC is the value here, and then it assigns that value to the data of the class. And then so I run this, and now when I say a.display, it actually displays the current value. So it runs the display method from the second class though, because you can see that there is no display method here. So it goes one up to call the display method. But when I say print, it actually prints what I wrote in this method, ctr with double underscore. So here it's like third class, blah, blah, blah. So basically, instead of running the print statement that we always use, it runs what we wrote here as ctr with double underscores. So this is actually called operator overloading. And also same for add. So when I say b equals a plus xyz, so a is actually the third class that we had. Remember, so we created a. So a is actually the instance that uses third class. And when we say xyz, it actually, and when we run for plus, it actually, what it does is, it runs this method, add, and it replaces this with ABC. And now it creates a third class where the input is self data, what you had here, and also ABC. So it will return ABC XYZ, basically. And now, since you created a new instance, B, you can print it, and it prints the way we just defined here, what we defined here. Okay. And also you can run this function mul, mul, which actually does is it only takes self data and multiplies with whatever input you give. So in our case, since that other is 3, so it multiplies what we had. So a data. Oh. It actually does it in place. So first we had ABC, but when we ran this, then it multiplied it by 3, and it returns ABC, 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 basically. And when we print it, it prints the way we asked it to print here. Okay. Okay, so now let's define a class which is really simple. That's just a namespace, an empty namespace object, and we can actually start attaching attributes to this class by assigning names to it completely outside of the original class statement. So let's say now I'm outside of class statement, and I can actually say rec.name is Bob, rec.age is 40. And once we have created these attributes by assignment, we can actually fetch them with the usual syntax. So here I say rec.name is Bob. But let's say, so now we just learned that how to overwrite the print. So I can actually define a method here. Let's say this. And so let's say I have rec.name. Is it upper function? Let me just test it. So if I have Sue, if I say upper, okay, good. So I can run that. So what I'm actually doing here is I'm defining a new method, str with double underscores, to overwrite print. And now if I run print again, print rec. Oh. Didn't run it. Oh, I forgot self. Let's see. Oh, sorry. Sorry, this is not an instance. I didn't create an instance. So let's say instance rec and print return non-string. Oh, we can type return here. Okay, let's do it again. All right. Because with instance I didn't define the name yet. So let's say Bob. Right, has no attributes. Okay, I think it's because we didn't define it at the beginning. Oh, it should be self. Right. All right, let's do it again. Actually, I want to try print rec. Okay, oh, finally. So basically, I was just trying to show that I can overwrite this print statement by just defining this string, a str function that actually just takes the name you had and returns an uppercase version of it. All right. But I want to delete it now because that wasn't the main purpose here. Okay. So now, but here this rec is actually just a class. We didn't create an instance from it. So we just defined a rec, and then we assigned some attributes. We defined some attributes, and then it still worked. So classes are objects in their own, even without instances. So they are actually self-contained namespaces. As long as we have a reference to a class, we can set or change its attributes as we wish. And now we can create instances that inherits the class names. So now, because they remember the class from which they were made, they will obtain the attributes that we attach to the class by inheritance. So now, since we defined name for rec, we can actually compute x.name, y.name as the attributes that they inherited from this rec class. But we can actually assign an attribute to an instance, so it creates the attribute in that object. So basically, let's say I create x, so x is the instance, and I change the name to Sue. But it only changes the name only in this instance x, so it doesn't really change it in the class that we just inherited, rec, or it didn't change it in the other instance, which was y here. So the attributes of a namespace object are usually implemented as dictionaries, and class inheritance trees are just dictionaries that links to other dictionaries. So if you want to see the attributes of a class, so let's say we had this class rec, and as I ran before, I can run this dict with double underscores, and since it's a dictionary, I can just return the keys, and I can wrap it up as list. So this actually gives all the attributes that this class has. So you see that we actually have, so we had these attributes name and age that we just defined, but it also has some other attributes that are supposed to be hidden to you. So you can think them more like private attributes. So in this case, what if I want to fetch the names without the underscore? Let's see. So are you guys also running all this in your laptops? So for this, I can say name for name in actually this. If what's name start with, right? That was the function. Oops. does it start with? Let's test this. So let's say I have a B C D and what was the function? Let's say string Python start with. Oh, okay, so it starts with, basically. What if I say, Okay, so it was starts with. Okay, so by just running this list comprehension, I can fetch the names that don't start with this double underscore. So this was the namespace for the class rec. But what if I want to fetch the namespace of x and y? So remember, x and y are the instances. So for x, it's actually empty. Sorry, for y, it is empty. So what did we have with y? So y is actually just instance of this class rec, and that class rec actually has nothing. So in this case, that's why we get nothing. But what if I check the namespace of x? Okay, so it has this attribute name as Sue, but what's the difference between y and x? Because for x, I actually defined Sue here. That's why it can actually fetch the attribute name for this instance, but not for y. So so you can actually access to the attribute name by either typing x.name for this instance, or you can actually say x._dict_name. So in this case, they both work. But if you use attributes, if you just use it like this attribute in a way like .h, for example, it checks the classes too. So for example, this instance x didn't have h as an attribute, but it actually finds it in the upper class to fetch this value. But if you use this dictionary method to do this, it actually raises an error. Why? Because again, so remember, the class had the h, so that's why x.h worked. But x.__dictionary didn't work because it only looks for the attributes for that instance. Okay? So you can actually see, you can actually use this class with double underscore to search for the attribute fetches. For example, when I say x.__class, I know that the class of this instance is actually rec. And also here, this main with double underscore actually comes from the fact that we are operating on the main file. We didn't import it. Remember, when we import, the name of the files are not main, but when we operate on that module, then the name of the file is main. So since now we are operating on a single file here, the name is main with double underscore. And you can actually also use this basis attribute with double underscore, which is a tuple of references to their superclass objects. So let's say I have this third class that inherits the second class. So in this case, when I run this, I can actually see that, oh, okay, so the superclass of this is actually second class. Or, for example, for this class, rec, you can actually, you get nothing because it doesn't inherit anything. So this this class, rec, it's an empty object. That's why when you search for basis, it only returns object. So methods normally created by a def nested in a class, but they can be created completely independently of any class object. So here, for example, I'm just defining a function that's upper name that takes an object, looks at the attribute name, and then takes the uppercase, converts it to uppercase. And here, it doesn't have to be defined even inside my class. So when I say upper name x, so here x is an instance, it looks for x.name, which was Sue, and then it computes the uppercase of it. You know, so basically your instances can be a function, can be an input to other functions. And they are not, they don't have to be defined in the class in nested way. Okay, but if we assign this simple function to an attribute of our class, it becomes a method now, and it's callable by an instance. So this was my class rec, and then I define a method called method as upper name. Remember, so here upper name for the function, it's just a name. So we just make sure that the method for that class rec actually points to the same thing, which is upper name. And then now we have this method for this class, and x is an instance that actually that was generated using that class. Now I can run x.method that runs the function that we just defined here. Okay. So I can do the same thing for the instance y. I can just run y.method, and it runs the function that we wanted. Or you can also call through an instance or a class too. So for example, here, so what is it doing? So it actually takes the class and then takes the method function, and then the input is my instance. So that input becomes this object here, and that instance or that object's name is Sue, and then it converts it to uppercase by just running all this. Okay, so let's stop for a second here. So is everything clear here, or do you want me to wrap up a little bit? Or you guys, maybe you should also start coding to get a better idea. Does it sound good? You want to do that? Or it's just Friday night? So but is it clear? Is it too easy or too difficult? Huh? Medium? Okay. So let's do this. So I want you also to start coding. So let's everybody start this PyCharm. Just open some file. Let's call this Lecture8 classes. let's now start creating our own little classes and look at how things actually operate all together. Okay. So now let's have. So can everybody have access to their pie chart? Can you start calling? Okay. So now let's have one class that's person. Okay. And let's say pass for now. Okay. And what else? So we are improvising here. What else should we do? Let's say we want to have a database of people in our company. And so we want to, again, we want to have employees, managers, and also we want to have this class person where everybody should have like name, age, whatever. Okay? So let's say we have another class that's an employee and pass. Okay, and now let's have another class, manager. Pass. And so here also let's have another class that's engineer. So now I just say pass just to remind myself that I'm actually going to implement all those. So in this case, so which one do you think should inherit another one? And also let's say we have should we have a class for engineer and manager? Not necessarily. Or okay, let's say class unicorn. Okay. Yes. So like super talented people, like data scientists. Okay. So in this case, what do you think we should inherit? So I have person, right? And all this should be a person, right? So for my employee, at least it makes sense to have actually a person, right? Okay, and so for my engineer, what should that inherit? Should I inherit just per employee, right? Okay. Should I also inherit person? I don't need to, right? Because it already inherits person. Employee already inherits person. Okay. So let's say I have a manager, and what should that inherit? Employee again, right? Okay. And all right, so for unicorn, so let's brainstorm on this a little bit. Let's say you can be both an engineer and a manager. So you are like a super skilled person that you can write the code and also manage a bunch of people at the same time. So for this, what should we inherit? We can inherit both, right? Yeah. And manager. Okay, so now back to the person. So what are the most specific things that I should have for a person that everybody has? Name, age, right? Like basic things. And for that, do I want to automatically start? Or do I want to automatically assign those attributes in person when I started? Makes sense, right? So for that, what method should I use? init, right? See, so actually PyCharm just added self by itself. It knows that I need self statements here. But it's not enough, right? So let's say we also want, what did we say? Name, age. Should we have anything else? Salary? Well, maybe not everybody works, right? I mean, we are just talking about human beings, Homo sapiens. So they don't need to have salary yet. What? Gender? Yeah. Okay. All right. And do you want to assign something by default to any of these? Maybe not, right? It doesn't make much sense. Okay. So now let's say I want to. So once I start this person, I want it to have this attribute name is whatever I input, name, and attribute age is whatever I input, age, and attribute gender, whatever I had as gender, right? I mean, you can also add, like, if name is not string, throw an error, whatever. You can add a bunch of tests here. But let's say we have this person so far. Okay, and when I'm writing this, I also want to make sure that I'm actually making sure that my code runs so far at least. So maybe I can add some test code at the bottom. So let's say one person. I create an instance and using a person class, and so I want name to be, let's say, Sue, let's say 25, and also, so for the gender, do you want it to be binary or just string? Have you decided? Doesn't matter much. It might matter maybe up to your program, but let's say, let's just say F for this, okay? So, and now when I do this, let's say I have print statement, one person dot age, one person dot, okay, let's make it name first, name, age, one person dot gender, right? Okay, so I can run this. Lecture8 classes. So I can run this. So see, when I ran it, it works. So basically, I just show that my class person works. So I just added a really basic test at the bottom. All right, so this works. So let's continue with employee. So what do we want with this? Salary? Okay. But should we have init method first? Shouldn't we have init method so it actually has, it runs the person? Okay. And now, so let's say it still takes name, age, gender. But here we actually, we never talked about it, but we needed to run the super class of this. What was the notation for it? Super class. Okay. Okay, let me look this up since we are improvising. So Python classes in its super class. I forgot the syntax. Okay, so basically, so this is like the syntax I'm going to use for now. You know, so it's okay that you might forget it, but that's not the end of the world. So basically here, super of employee in its name, age, gender. All right. Okay, so what does it do? So let's see what super was doing. For example, let's say I forgot. Let's actually look at the terminal here. EE551. So you can actually run IPython as an interactive shell. Let's say I forgot what super was. So this is the doc string for super. So it actually takes the class that you want. So here is a typical use. So you have a class C that takes B, and then you define a method, and you can actually say super of that method, and then run the method for the super of that, and then takes the arguments. Okay, so I got some basic information about it. So now let's test this employee class to make sure that this super actually worked. So let's say one employee. Okay, so employee class, and then let's say C25F, and let's say, okay, let's make it uppercase. One employee. Let's say if it will work. Okay, it worked. So basically what we had here is we told Python to create a class employee that inherits person, and with our init function that automatically runs, we actually look for the super class of this employee and then run the init of that class. So we are actually, what we are doing here is we are running the init of person that actually assigns all these attributes to the person. Okay, good, right? So we can do this. Now let's start implementing other methods for employee. So what can we say? So everybody has been told about salary. Compute salary, right? So it automatically adds self again. And then, so I mean, so there are different ways to do this. So we can either return some value here, or we can assign an attribute to that, you know. So let's say return again like 60K, let's say a standard salary, okay, for why does it complain? Okay, don't worry about it yet. All right, so compute salary is one thing, and what else should we have for an employee? Let's say number of vacation. Okay, and let's say for a standard employee, let's say I know 20 days. Okay. Okay. So let's say, so you got the idea. I can define as many methods as I want here. And now let's have our favorite class, engineer. And for this, what should we have? So for an engineer, should we have an init method again? You think it makes sense to have an init method? I think so, right? So let's have init. And again, like name, age, gender. And I'm thinking, should we also have some general attributes for an engineer? But anyway, so let's have this, and now similar to this, I can use the super class of this engineer, which is actually an employee in this case. And now, but so I want to have, let's say for compute salary, let's say since we are engineers, we want to earn more. Let's say compute salary, I actually return let's say 100K. Okay, and number of vacations, let's say it's the same. Okay, so let's say a standard employee and an engineer has 20 days of vacation. Okay, so now since I wrote another class, I actually want to make sure that I can run it. So I'm basically testing here. So let's say one engineer, and let's say this, and also, so we can print the name, age, gender, but we also want to print more complicated things. So let's say print engineer compute salary. Okay, so now I added this small test for the new class I just wrote, engineer. So let's run it. Okay, good, not bad. You know, so maybe we should also have the salary for the employee. Actually, I want to say salary for one employee. Complete salary. And here I want to say salary for one engineer and compute salary. Okay, so I changed my test a little bit. Okay, so this is the output. Salary for one employee is 60K, salary for one engineer is 100K. Okay, And is there anything I didn't test? So it's the number of vacations, right? So let's also test our number of vacations. Vacation days. For one employee, and also vacation days for one engineer. And let's run this. Okay, everything looks good, as it should be. Only salaries are different, and then we also have this vacation days, which should be the same for both engineer and employee. All right, now let's look at the manager. So should we get anything else for the manager? So again, name, age, gender, we like to have it. We like to start with that anyway. Okay, so let's also add something like the underlinks. So whoever reports to this this manager, you know, so we may not need that for engineers, but for manager we might need that. And also let's get people here. So so let's say this is going to be a list of names, and then let's say now instead of returning, let's say self underlinks is people. Actually, so for example, for this, since you are setting an attribute, I like to say set underlinks more. That actually shows that you are setting things. And instead of, for example, compute salary, it would be nicer to say maybe get salary, because we are not really computing, we are just getting, but those are really little differences. So, but in this case, let's say we set underlinks. And so let's test this. So now I'm going to have one manager, let's say Sue 25 F. And so I don't want to show the names anymore, but so let's get, but for manager, yeah, we should change the salary too, right? For manager, it will be unfair to engineers, right? So let's say compute salary. How much do you want to give to managers? More than an engineer or less? Less, right? I agree. Let's give them 90K. Okay, so now we have this manager, and then we want to have we want to see the salary for a manager. But for vacation days, I think we can give them more, right? Number of vacations. So let's say they have 25 days instead. So I'm testing my manager class. Number of vacations. Okay, this is vacation days for one manager. Okay, so I run this. Okay, so salary for one manager is 90K. Vacation days for one manager is 25 days, actually. Okay, so this is working too. So you see that I keep overwriting, right? So we overwrote both number of vacations and compute salaries based on the objects we are defining. I mean, I don't know. So let's skip unicorn now. I don't want to diverge too much. So I just wanted to show you how the thought process for designing your program and also interaction between these classes and also even the test method. But so now what happens? So let's say I'm in my Python shell here, right? Is it? Okay, no, this I want terminal actually. Welcome E551 Python. Okay, so now I'm in my shell. I'm just using IPython, and my location is this. So let's say I say import. Can everybody see? So let's say I say import Lecture8 classes, the module that we just wrote. So when I run this, it runs all my test files, I mean test cases. Let's say you want to use this module that I just wrote, but you don't care much about the test. You just inherit my module and then start writing your own test, and you don't really want you don't want to run all these tests every time you import this module. So what would you do in that case? Well, we talked about the name of a module, right? So let's say I say if underscore name is equal to underscore main, then run all this. Okay, so do you understand what I did here? I added this if statement at the top of my test cases. So I say if you run my code, let's say if I run this, it's still going to run all my tests, because when I'm operating on this module, when I'm running this, it knows that the name is main. So this is my main module I'm operating on. But so let's say in our terminal, so last week we talked about reload. So let's see if it works now. So how was it? We said from import reload. Okay, so reload Lecture8 classes. Okay, so it reloaded, but it didn't run the functions. Why? Because the name is not actually main anymore. Okay, so this was just a small illustration of how I can interactively test my functions or my classes, to give you an idea, and also how all these things actually interact with each other. Okay, so is the idea of classes more clear now to you?
Question now is class. Do we need a contractor of second class like employee and manager? I try to debate the contractor of second class, but it still work.
So which one? What did you do?
The second class
The engineer?
engineer or contractor.
The init?
Yeah.
Okay.
Like they still work.
Well, I think it works because they all look for this person. So remember, if it cannot find it in one class, it goes upper. So once it finds it, it
I think
stops.
it uses the constructor of person.
Instead, you use the constructor of the person. So basically, so you didn't use this super.
Yeah, this definition image is calculated.
So you just use person here.
No. You can comment on the init function. So the code
Oh.
to the upper.
Okay, I see. Okay, so you commented this out. Huh? Okay, so when we have that, employee, okay, so let's see. I see, okay. Right, maybe we don't necessarily need that. Let's see. Yeah, good observation. You are right, actually. Yes, I think what's happening is that so you will need these init functions only if you also have other statements. So in this case, since we didn't have other statements, it worked. But for example, let's say for manager, you have this init, but you also have like self is manager true. Let's say this. You know, so if you want to have some extra statements, then you will need that. Okay. So in this case, yes, it worked because since these didn't have init functions, so it actually just ran the init function that it could find only in the class that's in the highest level in our class 3. Yeah, but good observation. Yeah, but I also wanted to introduce you this super thing, you know, in case you want to run the methods from an upper class. Okay, so where were we? So a couple of weeks ago, we discussed about these records. If you remember, we had these tuples and functions of records. So let's say, so here in this case, we had this record of one employee, let's say, whose name is Bob, age is 4.5, and these are like these are the positions. Or you can actually define a dictionary where the name is Bob, age is this, all that. So there are multiple ways of doing this thing with the classes, which we almost did now. So basically here it just defines a class rec, and then it assigns name and age and jobs, and then you can actually operate on it instead of using the dictionary. So this is actually a better way, but we can actually make it even better. So we want a new class statement. So basically, we had this class, empty class, but now we create an instance by just running it, which is the person 1, and we assign values to it. We assign the attributes to it. And then we create another instance, person 2, and now we assign different things to the name and jobs. And then we can compute whatever attributes we want. But I mean, it's still not perfect, so we can make it even better, as almost what we did in the PyCharm. So we can define this more complex person class, where we can actually have all this information for each instance and then we can easily access them. So this is actually a better way of software engineering than writing everything with the dictionaries. So this way we have this class and we have instances for each person. Okay. So this was actually pretty much what we just did. Yeah, okay, so these are actually what we did pretty much. But so another small, actually it's not small, so something that you should pay attention is that, so let's say you also have different methods that you try to define. So let's say in this case, for this person, I actually try to extract the last name by just print approach. By this print approach. Or let's say I actually just change the value of the salary by just changing it in place. So these are actually hard coding things, you know. So instead of getting the last name of a person every time by just hard coding this statement, or every time when you want to give a raise, you want to instead of computing this multiplication, it's actually better to have a function that does all that. So let's say all you want is just getting a last name. So it is better to define a function that's like last name that runs what you want. So instead of defining it differently for each instance, or instead of giving raise by like hard coding the instance, it's actually better to write a function, let's say in this case give raise, and it actually changes the self.pay. So this idea is called encapsulation. So after polymorphism, so this is another concept that you should be familiar with. So basically it is wrapping up operation logic behind the interfaces so that each operation is coded only once in our program. So if I want to change the way I compute last name, all I need to change is this function instead of changing it in my implementation. So instead of changing computation of last name for Bob, Sue, or whoever differently, I just change this method. So it's just a single thing I need to care about. All the rest will be changed accordingly. I think that's pretty much it. So do you have any questions so far? Nice. Okay, so next week we will continue with classes with more complex, more complicated examples. Yeah, I think there will be a quiz, I guess, for the classes. So yeah, that's it for today. Thank you.